Friends, so let's talk about the relationship between two quantities variables. ABC produces a popular model of car, the sport car. The sport car has been on the market for 3 years, and the ABC company wants to gather information on the resale value of its old car. ABC research team suspects that mileage affects the final sales price of previously leased sport cars. They take a sample of 3-year-old previously leased cars that have been recently sold and record the mileage and sale price of each sport car. So what is the relationship between sales price and accrued mileage? Sales price and mileage are both numeric variables. We frequently encounter numeric variables that seem to be related. For example, there is a relationship between height and weight. Taller people typically weigh more than shorter people. So is there a relationship between the number of years of education someone has and that person's income? What about the relationship between the square footage of a house and its sales price? Why evaluate these relationships? There are several reasons. First, we may want to simply describe the relationship between the variables. This approach is common in exploratory data analysis. When we know very little about the variables and how they relate to each other, for example, engineers for an office supply company want to understand the relationship between the thickness of their plastic rulers and their flexibility. In other cases, we may want to set the value of one variable to control the value of another. For example, a manufacturer of steel alloys can set the concentration of carbon to the hardness of its alloys. Finally, when we know that two variables are related, we can make predictions about one variable based on the values of the other variable. For example, a hotel restaurant wants to predict the amount of money a guest spend on room service based on the daily occupancy rate. A scatter plot is the first tool we use to evaluate these relationships. This exploratory tool enables us to see patterns in the data and helps guide further statistical analysis. For example, look at this scatter plot of data collected at ABC factory. The graph allows us to see the relationship between production rate and UPH. As production rate increases, the UPH increases. The second tool we use is correlation. It uses a single value to quantify the strength and direction of a linear association. For example, the correlation between production rate and UPH is 0.832, which indicates that the two variables have a strong relationship in the positive direction. The third tool is simple regression. Simple regression provides an equation or model to describe the relationship between two variables. This regression equation can be used to predict future events. For example, ABC can use the regression equation to predict the UPH based on production rate. Let's return to the car lease example. The population of interest is 3-year-old previously leased sport car. We cannot collect data on all sport cars across all dealerships in the country. So we take a random sample. The team records the data on mileage and sales price. So how can ABC use the tools described earlier to examine the relationship between the variables? First, they can create a scatter plot to evaluate the relationship between mileage and sales price. The team can use correlation to quantify the strength and direction of the relationship. ABC can then use simple regression to develop an equation to describe the relationship. Let's review. To examine the relationship between two numeric variables, we can look at the pattern of data points in a scatter plot. We can we can calculate the correlation to measure the strength and direction of the relationship, and we can develop an equation using simple regression to describe the relationship and predict future events. Thank you for your listening. In the next lesson, we'll talk more detail about the scatter plot.